We're starting up on the fourth page of this practice test here, and we are given a triangle and its coordinates. And the things we're going to be asked to do is to find the midpoints and label them. We're going to ask to find a mid-segment, find the length of the mid-segment and the segment that it's parallel to, and then find the slopes so that we can verify things are parallel. So we got a lot of stuff to do with this once we graph it. But let's start by graphing it. We have b is -2, so back 2, up 5, and we're going to label it b. We have w, which is over 2, down 1. And I'm actually going to put the points right here as I go, because I'm going to find that's very helpful later on. And then the last one is p is back 6, down 1, or up 1. So make sure you label your stuff as you do it. Connect your points. You don't need to draw these perfectly, but the better you draw them, the better a check they're going to serve when you're checking your work and making sure things make sense. So next thing we're going to do is we're asked to find the midpoints of all of these and label them. So midpoint between -2 here and +2 is going to be 0. The average of 2 and -2 is 0. So I'm going to put that there. And then 5 and -1, a little less obvious, so I'm going to add them together and get 4, divide it by 2, and get 2. So the point 0, 2 is my midpoint. And if I go over 0 and up 2, you can see that it falls pretty close to my sketched line there. Now BW, that's the midpoint of BW, the first one, that's going to be called Q. So I want to label this right away so that I don't get goofed up later. Next one I'm going to do is this PW right here on the bottom, finding the average of -6 and +2. So I add them together to get -4, cut that in half, and get -2. So I add them together, divide by 2. I have 1 and -1, that's going to be 0, and divided by 2 is still 0. Now PW, or WP, is the second one, that's going to be called R. So I'm guessing the last one is going to be called S. We'll have to just figure out what its point is. Between -6 and -2, if I add those together, it's -8. Cut that in half, it is -4. I also have 1 and 5. Add those together, it's 6. Cut it in half, 3. And let's check, make sure this makes sense. Go back 4, up 3. Yeah, that looks like it's about halfway, so that's pretty good. And let's make sure I graph that one too. So now I've got all 3 of my midpoints graphed and labeled on the chart. Check. What is the name of the mid-segment in triangle BWP that is parallel to BP? Parallel to BP. Well, a mid-segment connects 2 midpoints, and if it has to be parallel to this, it's going to be this one right here. So it's going to be called QR. It connects the points Q and R. Throw a little line segment on top. Find the length of BP, then find the length of the mid-segment. Verify that one is twice as long as the other. So the length of BP here. We have a distance between B and P. We go from -2 to -6. So how far apart are -2 and -6? They're 4 apart. So I'm going to write down my 4. Then I'm going to check to see how far the y's are apart. I have a 5 and a 1. They are also 4 apart. So if I throw this into the Pythagorean Theorem, because I'm making a right triangle, by the way, if you're curious why this works, I go over 4 and up 4. I formed a right triangle. This is 4, and I'm finding the hypotenuse. So if you're ever wondering why we do that, that's actually why. Anyways, so we take 4 squared plus 4 squared, and we're going to square root that. So I end up finding the square root of 16 plus 16, which is the square root of 32. Now if I want to get a decimal approximation for that, I can plug that in my calculator. It's going to be 5 point something, we'll call it probably 5.6-ish. Next one we want to do is find the length of the mid-segment. So I'm going to go from here to here. And to do that, I need to figure out the distance between my x's, -2 and 0. Well, they're 2 apart. And then I need to find the distance between my y's, 0 and 2. They are also 2 apart. So Pythagorean Theorem again. I do that, and I'm doing 4 plus 4, and I'm getting square root of 8. Square root of 8 is going to be a little less than 3. We're going to call it 2.8 approximately. If you compare these approximations, the BP is in fact twice as long as QR, the midsegment, so that works out. If you know how to reduce these, you could reduce these to 4 root 2 or 2 root 2. If you don't remember how to do that from Algebra 1, that's fine. You can just use the decimal approximations and compare those. But otherwise, if you were to simplify these, you would see that one is twice as big as the other. Last thing we're asked to do is verify that the midsegment and that line are in fact parallel. The way that you verify that things are parallel is say that their slope is the same. So if one is going up like this and the other one's going up like this, we find the slope here. Say we get a slope of 1 here and a slope of 1 here, then they would be verified to be the same. Now the word verify comes up in all of these problems. That means do some algebra and check that it actually works. It doesn't mean say, oh, well, it's a midsegment, of course it's parallel, moving on. Doesn't fly. Verify means you have to do some algebra and check it. So let's do that. To verify the slope is the same for each of them. To find our slope of BP, we again find the distance between the y's first this time, not the x's. So let's start with the y's because it's rise over run is our slope, and we have a distance of 4 apart. And if we remember from earlier, we check our x's, we have a distance of 4 apart again. We can see from our line here that our slope is going up, not down, so we're going to say a positive slope. So this is going to be a positive 1. Now let's check the other one. We go from here to here, which means that we start with our distance between our y's, which is 2, and then we find the distance between our x's. Again, that's 2. Simplify that out, it's 1, and we see that our slope is going up, so it is positive 1. So we have a slope of positive 1, a slope of positive 1. They are the same, which means they are parallel. So that's what it means to verify. You actually have to do the work, look at it, and say, oh, this one is double the other. It is twice as long. These slopes are the same, so they're parallel. So you actually need to calculate it and then make the comparison. And that would check off this one here. So now moving down to the next page, we're asked to find x in this picture and then find LK in this picture. Now in this picture we have a triangle where we have a midsegment. And the reason I know it's a midsegment is if these two are the same length, this is the midpoint. If these two are the same length, this is the midpoint, and something that connects two midpoints is called a midsegment. So I know that if I take this smaller piece, and double it, I'll get the bigger piece. So a few ways of writing this, but I'm going to write it this way. I'm going to double the smaller piece and set it equal to the bigger piece. I distribute that out and I get 2x plus 36 equals x plus 28. Subtract 28 from both sides and I get 2x plus 8 equals x. Subtract x from both sides and I get x plus 8 equals 0. Subtract 8 from both sides and x equals negative 8. There's probably more efficient ways to do that, but either way I get to x equals negative 8. Now if I want to make sure I get this right, I should check it and make sure it works. So if I plug in x equals negative 8 here, negative 8 plus 18 would be 10. If I plug in negative 8 down here, it would be 20. 20 is twice as big as 10, so it seems pretty reasonable. Next question I'm asked is if LD is 10, if this part here is 10, notice I'm always labeling my picture when I get information in a problem, and KC is 7, KC is 7, What is LK? What is LK? Well, if this piece right here is 10, and I know that these two are the same, then this is 10. This is why I use the picture. So the whole thing has to be 20. And that's it. This 7 over here was extra information, completely irrelevant. This 10 and 20 that I calculated earlier, not useful to this part of the problem. So sometimes you have more information you need. Be careful. New problem here, we have a perpendicular bisector. And the reason I know that is because I look at this triangle and I see this line going through that perfectly splits the bottom. It bisects it. It cuts it in half. I also notice a little right angle mark, which means that it is perpendicular, or meeting at a 90-degree angle. So, a couple things I get from this perpendicular bisector. One is that these two chunks have to be the same. And if we're asked to solve for x, I can set them equal to each other. And so I can subtract 3x from both sides, and I can subtract 2 from both sides. And when I do that, I end up with 4x is equal to 8, or x is equal to 2. So x is 2. Again, if I want to check, I plug it back in. I get 2 times 3 is 6. 6 plus 10 is 16. 2 times 7 is 14, plus 2 is 16. It works. Next question, totally different ball of wax. We're talking about angles. So if angle U here is y minus 30. Again, notice how I'm drawing in on the picture what I'm given in the problem. And OAV, this angle right there, is y minus 90. What is angle O? Now, we remember perpendicular bisectors essentially give us a perfect mirror of everything going on when it goes through that top point of a triangle like that. So everything on either side of that mirror is identical. So since I have information on both sides here, I can know that this here is also going to be y minus 90. And if I want to figure out angles of a triangle, I need to use all the information I have. And I know that 3 angles in a triangle are going to add up to 180. So that orange triangle right there, I have a 90-degree angle, I have this here, and I have this here. Let's solve this. So I have 90 plus y minus 30 plus y minus 90. And all together that equals 180. Well, a negative 90 and a 90 are going to go to 0. Clean this up, I have 2y minus 30 equals 180. I have 2y equals, add 30 to both sides, 210. Y is 105. If I plug y is 105 back in here and subtract 30, then this angle is going to end up equaling 75 degrees. Now, why do I care what angle U is when I really want to know angle O? Because this is a perfect mirror. And if this is a perfect mirror, angle O and angle U are the same, which means that angle O is 75 degrees. If I want to check myself, I could plug that 105 up top. 105 minus 90 is going to be 15 degrees. And if I have 90 plus 15 plus 75, that'll equal 180.